students, hope you are great. Today we're going to take chapter 4, arrangement of electrons in atoms. Section 1, light has characteristic of both particles and waves. Scientists first thought that light behave as wave. This belief changed when it was later discovered that light also has particle-like characteristics. So, first scientists thought that wave behave as that light act or behave as wave, but now he discovered that light also has particles characteristic. So light has characteristic of both particles and wave, which is called dual nature of light. Visible light is a kind of electromagnetic radiation. Look, this is a visible light. It's a kind of electromagnetic radiation, which is form of energy that exhibit wave-like behavior as it travels through the space, as invisible light can travel through the space. And it's also kind of electromagnetic radiation. So, what's meant by visible light? Visible light is a kind of electromagnetic radiation like radio, microwaves, infrared, visible light, ultraviolet, X-ray, and gamma ray. Like all these waves. So it's a kind of electromagnetic radiation and also can travel through the space. Other kind of electromagnetic radiation which is include X-ray, ultraviolet, infrared, microwaves, and radio wave. Together, all kinds of electromagnetic radiation are grouped in the electromagnetic spectrum. This is called electromagnetic spectrum, which is include X-ray, radio, microwaves, infrared, and so on. Electromagnetic radiation move at speed of any form of electromagnetic radiation is constant. So the speed of electromagnetic radiation, whatever radio, microwave, infrared, visible, ultraviolet, X-ray, or gamma ray, all move at speed which is constant, which is equal 3 times 10 power 8 meter per second. So the speed of electromagnetic radiation or of the light is a constant which is equal 3 times 10 power 8. Characteristic of waves. Waves have characteristic. Wavelengths. What's meant by wavelengths? Is a distance between corresponding point on adjacent wave. Look at this picture. The distance between these two points, this is called wavelengths. Look, for example, the first one has long wavelengths while second one short wavelengths. So what's meant by wavelengths? Distance between corresponding points on adjacent waves. Between 2 points, look, like this, between 2 points this. The unit of wavelength is a meter, so we can measure this wavelength by meters. Second characteristic, which is frequency. What's meant by frequency is defined as number of waves that pass a given point in a specific time. Number of waves divided time. Number of wave divided by time. This is called the frequency. How many wave per time. This is called the frequency. So frequency is expressed in waves per second, or number of wave per time, measured in wave per second, and also can measure frequency or unit to measure frequency, which is called 1 per second, which is equal hertz. So another unit to measure frequency called hertz, hertz. So frequency, how many waves per second. For example, here we have how many waves? We have 1, 2, 3 and half. Second one, we have 1, 2, 3, 4, 5 and half. So second one, 5 and half. So which one has a higher frequency? Second one, as the number of waves more than in the first one. The mathematical relationship between frequency and wavelength is written as follows. Look. Relationship between frequency and wavelengths. Speed, which is equal C, equal wavelength times frequency. As the speed of the light, and C is a constant, 3 times 10 power 8 is the wavelength, while this is the wavelength of the electromagnetic radiation, which is in meter, and V, which is the frequency of the electromagnetic radiation, which is in the unit to measure frequency, 1 per second, or second -1, or hertz. This is a unit to measure frequency. Wavelengths and frequency are inversely proportional. Look. Wavelengths and frequency inversely proportional. So when, for example, an electromagnetic radiation with a very high frequency will have a very short wavelength of gamma ray, X-ray, and so on, or any kind of electromagnetic radiation. So wavelengths, when a wavelength increase, the frequency decrease. As the relation between frequency and wavelengths are inversely proportional. When a wavelength increase, frequency decrease. When a certain frequency of light strike a metal, electrons are emitted. When a certain frequency of light strike a metal, electrons are emitted. Scientists conducted 2 experiments involving interactions of light and matter that could not be explained by wave theory of light. One experiment involved phenomena known as photoelectric effect. What's meant by photoelectric effect? Refers to emission of electrons from a metal when a light shines on the metal. Look at this. This is a metal. Inside the metal there is an atom. What happened to this atom? When the light wave strike or hit this metal, what happened to the atom, or what happened to the electron that present inside the atom? It will emit. So emission refers to emission of electrons from a metal when a light shines on the metal, or when a light hit the metal. This effect called photoelectric effect. So if we have metal like this, which include in the metal there is an atom, in atom there is an electron like this. When light wave hit this metal, what happened to the electron? It will emit like this picture. No electrons were emitted if the light frequency was below a certain minimum regardless of the light intensity. Light was known to be a form of energy, so the light is a form of energy capable of knocking or lose an electron from the metal. But the wave theory of the light predicted that light of any frequency could supply enough energy to eject an electron. Scientists couldn't explain why the light had to be of a minimum frequency in order for the photoelectric effect to occur. So, for this example, the light wave must have energy that's capable to emit these electrons, as if the light waves or the energy of this light wave less than energy of the electron, so this electron cannot emit or cannot lose. While if the light wave or the light rays have more energy, or have high energy, so this light wave can able to emit this electron. This called So no electrons were emitted if the light frequency, if the frequency of these light waves was below the certain minimum regardless of the light intensity. That's it. Thanks for watching.